Hi, how you doing? Can you hear me? Actually, I gotta stare at the screen over here for a minute just to make sure you can hear me. It looks like you can hear me. I see a bunch of little lines moving. That usually means I'm in the right direction. But hey, hi, how you doing? I'm Tom, and this is my lift and shift stem steam engine. I've been doing this for a while now, and eventually people are gonna start watching. Sorry, just just I've got a dark sense of humor. So I'm the founder of the Lift and Shift Foundation, and I help veterans on the design team. We have a design team that helps give veterans access to behind the scenes type stuff for the program that I built, and it's really fun. We do these things where we battle robots all the time, and we were actually meeting earlier today. The plan was to talk through some of the things we're going to do and how we're going to build the program for the robot battles. Excuse me. Excuse me. Sorry. It's 8 p.m. here in New York City, and I'm still wearing pants, which is weird, but I'm on a roll this week, so let's we might try for 5 days straight wearing pants. I think our days indoors are kind of over, but yeah. So what you can probably see up there is I've got some parts. I took a robot apart, and I'm gonna do a quick recap. I don't know if anybody can hear that, but that's my crazy little fan. I actually made this crazy little fan like this. It's attached to my radiator, and occasionally it goes crazy because I didn't put any padding around it. But I threw a few fans together. They're 5 volt. They're actually spliced into a broken USB cord and plugged into the USB port on the wall block. Excuse me. Works out well. I highly recommend it if you know what you're doing and you're not going to start a fire. It's the kind of thing that will do that. So don't try it if you're not skilled. But anyway, back to some of the other stuff that we're going to hack and chat and talk about today. I'm going to recap some of the cool things I did over the last couple of weeks. Is one thing that was really like low tech, really just like low hanging fruit for us. It was like the easiest thing ever, and you can see it up here on the screen. I'm gonna zoom in. Check it out. Look at that. I made this panel. I 3D printed this tiny little panel, and you're gonna come back. You're gonna come back here. Come back to me. I'm gonna flip screens a lot. Hope I get it right today. But we're gonna get into this because what I have here is our Ranger robot tank, and oh yeah, it's still got the sticker logo on it and everything. And our pals at Sane Smart sent us some cool toys we're gonna be playing with later. Maybe next week. They'll probably be here tomorrow or Monday, so maybe next week I'll be able to play with some of them. But we'll definitely be doing some cool stuff with them. Some big LED panels and other stuff. I'm going to share them. We'll probably write something up or something cool. But anyway, back to the robot here. I could probably stop and get up and get a glass of water. I don't think anybody'd miss me. But the batteries, you kind of see them. They're sticking out. They're showing here. They're very visible. They're very out in the open. That wasn't the case a few weeks ago. In fact, if you caught the last Battle of the Bots that we stream here, you probably noticed that there are no batteries sticking out like this. We use this plate to move the battery box, and it worked out really super well. I'm so happy with it because it was like a 45-minute print, and it was I don't know, an hour of throwing the design together. So it was really low and easy, low tech and easy. That's the word I was looking for earlier. To move the battery box from under this controller, this brain, the motherboard for the robot, to way back out here. So when the batteries fly out or they go dead, which happens a lot, they're easier to swap now. So our robot battles drag when the batteries come out because it takes 5 minutes to change batteries. And we wanted to minimize the battery swaps, but still have the batteries accessible. And we kind of think it's funny. We laugh. We get a kick out of it when we knock the batteries out of the opponent. So this gives us the option to do all those things. So the batteries are there. They're on the back. If this bad boy goes over, these batteries are still going to come out. I can't wait to test out my hypothesis that it'll actually be harder to do it because of the center of gravity and torques and levers and things, all the engineering mechanics behind it, the statics and dynamics classes if you've had them as an engineer or as a physics student or any of those kind of nerdy type people. That's me. I'm a nerd. Yeah. Shh, don't tell anyone. Chicks don't dig it. But anyway, so here I am. I'm back, and I want to start doing some other modeling and other hacking and other changing of the robot. That's how I'm going to say it. So one problem we have with the robot matches is, do you see this little panel? This little panel sticks out on our robot. I'm gonna show you right up close. This panel right here sticks out. Hey, how you doing? So this panel sticks out on our robot, and as you see, that these eyes usually go right here, like that. So when our robots are fighting and they're stuck together, they occasionally catch right here, just like that. And you can see they get hooked. I can hook them on there like that. This creates another drag for us as far as the robot battles are concerned, because the robots get locked up and we have to call it a draw, and there's no winner there. So when we're doing this, we have problems because these eyes are just like jutting out. They're just sticking out. They're there, and the same with this. And these are the 2 points where they catch. So we want to hack one of these surfaces and create a mask or some kind of add-on to one of these spots so that they can slide past each other. And that's where I'm going to leave the design and ideas up to anybody and everybody. What I'm going to do today is give everyone the tools to be able to make their own ideas come to life. So I have some ideas on what the result looks like. I'm not going to share them. Next week, actually, we may share the results, and hopefully I will 3D print some things from the design team, or maybe we'll land on an idea and I'll work through the slicing and things next week. We'll see how that goes. It's not supposed to be a stressful project. It's supposed to be a fun project. So today I'm going to take time and I'm going to put this in a place where we can use it, because we want to add a part to this. And you can call it a face mask. You can say we're going to give our robot its own little face mask. We can make a new face for him. We can do like a Mr. Potato Head and stick something in there. There's all kinds of ways to deal with this. But the one problem I have with 3D printing a part is I can't help this dude without some kind of software to design a part in. So I'm gonna take the focus off me right now, and I'm gonna leave my part right out here on this screen. Hey, hi, how you doing? And instead, I'm gonna disappear, because that's my favorite part. Poof, and I'm gonna head over to Tinkercad. I will switch back and forth between these two screens right here for the remainder of this, but I'm gonna start with modeling this project in Tinkercad. And here we go. So this is my plate. You can see my plate here, and as I zoom in on this, you can see my plate. Here's my plate right there. It looks a lot like that plate up there. I printed this quickly with like some basic settings. And so there it is. There it is again. There's the plate. This worked out great. So I'm going to keep this workspace open, and I'm going to design in here. So I'm going to design a new part. We're going to just grab this plate and we're going to push it aside. And I'm going to rename this file first of all, and we're going to call it Ranger Hacks, because Ranger is the name of the robot. So Ranger Hacks is this workspace, and it's going to work out really, really cool. This is where we're going to keep a lot of our design ideas and drawings. But the first thing I tell everybody, and if you haven't caught this in the past, then you haven't watched and you haven't paid attention to me, or you haven't been in any workshops with me or anything like that. So you don't really get this, but it's tremendously difficult to have fun modeling and to be efficient modeling here if we don't have the parts in the workspace. So today I'm actually going to recreate this little guy right here. I'm going to recreate him in this workspace right here. So, excuse me, once again, I have everything set up now so that I can do that, and I can grab my caliper and transfer all the measurements on the face of this into Tinkercad over there, so that me and the design team, we can all take shots at coming up with our own project and our own idea of what works here and what doesn't work here. So just one last come back to me. The goal of this project today is not to actually build our hack or our mod, but we need our parts in the workspace to work with them. I have them here in my hand, and that's super cool. I love it, but it doesn't help us if we can't work with it in this digital space right here. So I'm gonna do the heavy lifting with the caliper, and we're gonna make this guy right here. We're gonna make him show up in our workspace, and we're gonna do it because I do have that shape. So maybe we look for that shape right now. So I can kind of find that shape, or maybe in here. Tinkercad has a great assortment of parts, and I'm kind of scrolling and hoping I come across it. Oh, right there. Look at that. So check it out. That is almost our part. And if I lay this flat, so you'll notice there are a few differences in this part. This part doesn't have the same shape. So if I zoom in on both of these, you can see they look, where'd you go? Similar, but there's this bottom part that has the screws that we need, and I don't know the measurements on this, so I can't say that it's exactly the same size. In fact, we can do that. It's 45 millimeters across on that board. So what I'm going to do is I'm going to measure our part here and see if they're even close, if I can even use this. So already you can see that our part is 55 millimeters. Our Makeblock eyes here are, there you go, are 56 millimeters, whereas Makeblock or Tinkercad model is at 45 millimeters, and you can't change this, you can't adjust it. So the stock part that we would use won't fit for our needs, and that's okay. That's cool. We can still work with this. So we will design something that looks just like that, and I will delete that part right there. We'll just go back to all of the basic shapes and start right over from scratch. I'm going to drop a panel here, and we're gonna do this the hard way. I'm gonna let's measure. Let's measure. We're gonna measure how thick this is. Board is like 1.5 millimeters ish. 1.6 millimeters. So our board is 1.6 millimeters right there. So we will make some parts that look just like that. We're gonna make this about 1.6 millimeters tall. Poof. And what did I say? 56 millimeters wide. There we go. Now we're starting to get the shape. Oh, wrong number. We're starting to get the shape right there. So that's getting close to the shape here. How wide is the rounded part? I'm going to call it out instead of switching screens because it's not this screen switching was not working out for me. 24 millimeters. This is 24 millimeters that way. You can see it right there. So we're going to go with 24 millimeters. right there. I'm going to try 24 millimeters. Nope. Undo. How about 24 millimeters that way? So that's the basic shape. Very cool. So we've got the basic board down. I'm not going to worry too much about the rounded edges. I'm going to leave the rounded edges off because in Tinkercad, that's a little more complex to do. So we would have to go and find a shape generator, which is down here. And, well, I'll find it just for now. There's a part called a fillet. And it's basically just the inside part of the round thing. And it's going to make me scroll and scroll forever until I find it. But I'm gonna find it because now I'm on this journey. That's close? We're getting close. It's way down here at the bottom. It makes it all awkward. We could probably use that no, we can't use that cycloid. Rounded cube, nope. We're getting close. We're looking for something called a fillet. Right there. Meta fillet. So what we would have to do is set this to a size like that, like let's go 5 by 5 and make it a hole, and I'm going to duplicate it and turn it 90 degrees. And then we'd have to cut it out like that. So I could be doing this for quite a while of kind of cutting these parts out, in and out. We would have to do this. I would have to line them up. This is how it's going to work in Tinkercad. This is much easier to do in SolidWorks, or not SolidWorks. Fusion 360. And we can actually flip this like that. I forgot about flip. Dun, dun, dun. There we go. So we can line these up this way. Cut, line these up this way, cut, line these up, and cut. There we go. So now we've got a board. We've got the actual board that's shaped kind of like this. Right? Now we've got to add this bottom part down here, and that's going to be a little bit challenging. We're going to go back to basic shapes. I think there's a four-sided, nope, apparently not. I thought there was a four-sided, no. Nope, I don't have any favorites. I don't have my own creations. So what we'll have to do is add another panel, make it 1.6 millimeters tall. Hi, how you doing? 1.6 millimeters tall. And let's come back to our part here. I'm going to measure how tall that is. And I'm going to use the outside mark here. On the outside you can measure distances, whereas in here you can mash your finger inside and measure how wide your finger is. Here you can measure the distance between two fingers. So that's kind of cool. And I'm going to use that right here because I'm going to set this on there and we're going to measure that way so that I can tell you this part is 11 point 12 millimeters, almost exactly 12 millimeters across as I make that mark. So we're going to make this part 12 millimeters deep. Oh, this direction, 12 millimeters deep, like that. Now we need to round these corners, and this is going to be important because as we run into this problem, you kind of, I'm going to spin it this way so you can see it looks a lot like the red dot over there, or the red part over there. It's starting to look a lot like that as a shape, right? So that's cool. We're getting there, and it's got this kind of tapered bottom. So what I'm going to do is I'm going to measure the top part and the bottom part, and we're going to create two triangles to add to this, and that's going to make our part. So I'm going to measure the very bottom, and that's going to be as wide as we go with our part. I'm going to do this right there, and we're going to say that's I need to get my face right up in it, so give me just a second as I do this. I'm going to try to be as exact as possible with this. I'm going to try to be a little anal about my measurements and my stats and things, because this is a sharp edge. It's not a rounded corner like we did earlier. So I'm going to say this is, if I come back now that it's exact, almost exactly 24.5 millimeters is what I'm going to say that is exactly. So 24.5 millimeters. We're going to set that down. I'm going to come back to this and say, we're going to say 24.5 millimeters. There we go. So that's as wide as that part is. And I can do this number and align them in the center. And now they're starting to look similar, right? If I do that, it's starting to look like the shape of our part. I'm psyched about that, but now we need to do the triangle part. So I'm gonna do this and make this 1.6 millimeters thick. Cool. I'm gonna change the part to red so that I don't get confused. Now I'm gonna turn it flat, 90 degrees. I'm realizing now that I should have used a different part now that it's flat, because the right angle, the 90-degree angle, is over here in this weird spot. So I'm going to delete that. This is going to make my life a lot easier, and hopefully a lot of other people recognize this. I'm going to use this part where the edge is flat on the surface here, and hope that works out better for me. I'm going to make this one 1.6 millimeters. And now we're going to rotate this 90 degrees. There we go. So now my shape, when I click on the shape, I have the corner, the 90-degree corner in a corner, and that's going to help me a lot. So, what did I say this was? 12 millimeters tall. We're going to make this, we're going to shrink this down to 12 millimeters, like that. And now, here comes, I'm going to have to do some math. This is my disclaimer. It's Thursday night, about 8:30. Nobody likes math to begin with. I talk about math and people just kind of, I'm like the teacher on Charlie Brown. Nobody's listening. So I'm gonna do the math, and I'm gonna talk through it, but ignore me. Put some music on. Do something fun. Math is boring. Nobody likes it, but we do use it occasionally. This is gonna be a little bit of trigonometry and geometry stuff. So I'm gonna go back and we're gonna talk about triangles. Okay, so now that I've given everybody the warning, what I'm gonna do here is I'm gonna measure all the way across the base of this as far as it goes. Like that, until it feels like it's coming up off the bottom. Like that. And we're going to say this is 38 millimeters. That's 37.93, and it feels like it's just starting to come loose a little on the bottom. So we could easily say this is 38 millimeters right there. Yeah. So we're going to go with 38 millimeters across. Cool. So I'm going to set that down. So 38 millimeters, and this was 24 and a half. So I'm going to take a note. Say 38 millimeters minus 24.5 is the space we need to fill in this. And then, so that's X, right? And then we need to divide X by 2 because we have 2 parts. So we need to divide the whole thing by 2. So that's our equation, right? So we can rewrite that equation. And I'm gonna do some fun math. We need to get rid of the parentheses first. In fact, I'm not going to do the equation, the actual function, the math. I'm going to say that 38 minus 24. Actually, sorry, I did this math wrong. Let me go back. Divide by 2. That is our answer, is our question. And this side here is all, it's all numbers. There are no variables. So when it comes to algebra, we can solve this easily. We can say that we can break this down. And I'm going to do it step by step. I'm going to say inside the parentheses we know is 13.5. Oh, hey, back. 13.5 divided by 2. I keep mashing the same buttons on my keyboard, and I have hotkeys set up, so it's driving me nuts. I apologize. Here we go. So, as I'm doing the numbers here, so now we're down to 13.5 divided by 2 is equal to X. So I'm going to take this a step further, and I realize people probably can't see this, so I'm going to zoom in, make it big and annoying. So now you can probably see my math. Let me move my container here. So these are the numbers we're working with, and let me just confirm the numbers. We said that's 24 and a half, and the piece I measured was 38. So 13 and a half divided by 2, and I'm going to do this the easy way and say that 14 divided by 2 is 7, right? So we know that this is just less than 7. In fact, we know that this is 1/4 less than 7, so we can say 6.75 equals X. So this side here needs to be 6.75 millimeters. Poof. There we go. That is all the math I'm going to do today. Big disclaimer. That is all the math I'm going to do today. I'm not going to bore people. I almost fell asleep doing it. I'm going to be honest. Okay, so here we go. Let's go back. I'm going to zoom out from my Tinkercad window. I like to use my box open all the time, so I zoom out. And it's just a tip for Tinkercad. Something I do all the time. I dig it. I like it. Yeah, I should make a... I need to rethink my hotkeys and maybe move them to the number pad. Yeah. But anyway, so I just did some boring math, but I came up with the solution for us. So I'm going to delete the math now. I'm going to make this go away. We're going to throw it away because let's just pretend it never happened. It's math. And I'm going to duplicate this part. I'm going to move it to the other side, and I'm going to flip it this way. There we go. So we can start to see our part take shape. So what I'm going to do now is grab the parts and line them up. I'm going to grab all three of those parts, and I'm going to line them up on the correct center. And I'm going to zoom in as close as I can right here so we can see. Oh, they're not even anywhere near each other. Look at that. I got to drop this down to 0. Drop this down flat. Right there. Let's drag this over some. And I'm going to snap my grid here so I can use my keyboard. And I'm going to line these up so that they're super, super close, super, super perfect. That is just the tiniest bit of overlap right there. Can I go even smaller? I can't go even smaller. So we're going to go with that. And I'm going to slide out. And we're going to zoom in on this guy. We're going to go the F key to fit. And I can just barely see some light in there. So I don't think they're touching. So I'm going to go here. So we're going to be off by 0.2 millimeters on the shape here. And I'm good with that. I think that works. What we're going to do is combine these three shapes now into one solid shape. Check it out. Oh, we got a line in there. I got to undo it. That was too separated. So I'm going to snap that over just a tiny bit. And combine them. And now you don't see the seam in there. You don't see the line. The line is gone. So that's the signal to us that we put these parts together right. So now I'm going to join these up. I'm going to line them this way. And I'm going to do the same thing here. I'm going to get my face right up in it. And click on this part and slide it up until I see no crack in there. Right there. Dun dun dun. Super cool. There we go. And when I join it, there's no seam anymore. So I got it. I got it good. I got it right. There. That's our part. Check it out. Tell me that doesn't look close to this, right? We're pretty good. That's it. I'm gonna wave this around till I get it in the middle. Check it out. So now we need to add these holes and these little sensor cones. These are actually sound transducers and receivers, and they listen at sounds above what people can hear, kind of like a dog whistle. So one sends out the sound, the dog whistle sound, and one listens for the dog whistle sound. And depending on how long it takes to bounce off of something and come back, your robot does the math and says there's an object in front of me. So those are kind of cool, and we can easily make those, right? So we can let's do those first. I'm gonna grab them. I'm gonna say that is almost exactly as I get a little wiggle there. That's 15.9. We'll be a little gracious because if we make a part, we don't want it hitting this. So I'm gonna be a little gracious and say 16 millimeters. That will give us like 0.1 millimeters of play if we do make a part that fits on there. So 16 millimeters. And so let's come back to our platform here, our workspace. I'm going to drop in a circle. And we're going to make this 16 by 16, poof. And I'm going to drop down the cylinder menu because I'm going to crank the sides up as high as it goes to make it really round. Did you see what I did there? That's something I do on every part. It doesn't come like that. It comes with this like weird shape where it's got like 12 sides. I crank it up to 64 sides so that it's actually smooth on the outside. So that's the shape we want. But how tall is this part? How tall is this? This is my favorite part about my digital caliper is this part measures height. There's a little stick that comes out of the end here. So you can see it. Check it out. This part, as I give a hint here, this part extends as the bottom comes out because it's attached to here. You can see it's attached to here. So check that out. So I can pull that part out. But what it does for me is, as I'm like a kid with a toy, it lets me measure the height. Just like a depth gauge or a feeler gauge, kind of like micrometer type thing. So I can push down. Let me get this lined up right. I can push down here and come up with a right number of 12 and a quarter millimeters, 12.5. I'm going to go very detailed on that one. Actually, I'll go 12.5 millimeters high. Poof. 12.5. Just like that. So that's the size of our sensor. So I come back here. Very cool. And we have two of them. So we've got two of them. Now my question is, how far apart are they? So here's the fun part. I could try to struggle and place these in here and do this, right? And then I've got to try to line them up. And it's not going to work out right. And then I've got to lift them up 1.6 millimeters. So I'm going to lift them up. 1.6 millimeters so that they're off the plate. You can see I did that a little too high by hand, but then I've got to try to like line them up. And I could spend a lot of time struggling here to make them centered, but that's not going to work so well for me. So watch this. If I try to center them this way, it's going to put them right in the middle. If I try to center them this way, it's going to put them right in the middle. It's going to make everything awkward for me. So I'm going to cancel that. I'm going to drag these two parts. Oh, maybe I'm not going to drag anything. I'm going to drag these two parts over here, and I'm going to do something different. I'm going to spread them out like this. And I'm going to work with the eyes. I'm going to line these eyes up this way. So now the eyes are this lined up just like our eyes here. And I'm going to measure the distance. So come over here. I'm going to measure the distance between these two eyes like this. So check it out. Our eyes are 16.15 millimeters apart. And that's, we'll go with 16.1. We'll go with 16.1. It seems to be a little bit of play. I'm going to give a tiny bit of play. I'm not going to be terribly angry exact about it. 16, I could probably go with 16.05, really. So we're going to go with 16 millimeters, actually. And I'm going to spread these out 16 millimeters. So I'm going to put them together like that. And I'm going to use the ruler right there. I'm going to drag this one 16, what I think is 16. So we're going to go 16 right there. So now I have them 16 millimeters apart. Let's make sure I have the ruler right in the dead center. Zoom in on that ruler. We're going to dismiss the ruler. I'm going to put the ruler right on the corner of this part. And that's 16.30, so I'm going to do 16. Okay, cool. So now our eyes are split. And now I'm going to do something even better. I'm going to group the eyes together. So our eyes are up high enough, and now they're 16 millimeters apart, so that they're a group. I can move them around as a unit, which helps me tremendously because now I can center them on our part like this. Poof. Cool. Starting to look like this. Oh my gosh, I am a moron for not showing you all of that up close. But we're starting to look a lot like this. And now I'm going to measure, just to make sure, how far this is from the edge right here. I'm going to do the same thing I did earlier. As I flip screens back, poof. We're going to measure the distance using the opposite side. And we're going to say this is 3.944 millimeters from the top. So our sensor starts 4 millimeters from the top. And that's what I'm going to use to line up our part. So once again, I'm going to drop a ruler right there. I can't really see the ruler. Actually, I'm going to dismiss the ruler. I'm going to put the ruler right on the edge of this. And we're going to spin the ruler. There we go. Spin the ruler that way. And we're going to measure there. And we see that right now it's 3.9 millimeters. So I'm going to make it 4 millimeters. And it shifted just enough for us. Cool. And I definitely got that on the good corner. So now we've got all of our parts together. Yes. I'm starting to dig this. This is a cool project. So I've got this. And I want to make this a multicolor. I really want to make it multicolor, but it's not going to happen. And once again, I've done the unthinkable of not using the big screen. It's because I'm watching. You know what? I'm going to turn off my big... I can't do that. I would like to, but I can't. Okay, so I'm just going to join these now, and we're going to do that. So now we've got this part. And it looks a lot like our eyes here, right? If I do this number, starting to look just like it. Now we've got to add these holes in the bottom. So we've got these holes in the bottom, and they're missing from our part. And there's some other little bumps and nodules here, but I'm going to leave those out for right now because we can always trim a plate or something off of those. But we need these holes because we need to attach parts to them possibly. So I'm going to come back and measure these holes. And that's where my fancy little inside measuring thing works out just as well. It's to say that these holes are 4 millimeters wide. So you can see 4 millimeters right there. Dun dun dun. 4 millimeters is this hole if I push on the edge here, right like that. So the holes are 4 millimeters wide, and we have 3 holes. So let's make some holes real quick. Let's come back. Let's make some holes. I'm gonna, like I did before, I'm gonna crank them up. I'm gonna bounce 4 millimeters and 4 millimeters, and there's our hole. The holes are so much easier. And what I'm gonna do here is I'm gonna use another feature. This is gonna be fun. Ready? Let's come back. I need to make 3 holes, right? So let's check this out. Let's see how far apart are these holes. I can measure inside like this and tell you these holes are 3.9 millimeters apart. Let's measure the other ones and see. Oh, just a hair off. 3.9 millimeters apart. That's pretty precise. 3.9 millimeters. That's actually like oddly precise, like that's made specifically for something. But we're going to go with 3.9 millimeters. So I'm going to come back to our space here. What I'm going to do is I'm going to duplicate this. And I'm going to move it over. Let's do this. I'm going to snap grid to 1 millimeter. So this hole is 4 millimeters wide. So if I move over 1, 2, 3, 4 millimeters, now they're touching each other. So now I'm going to move over 1, 2, 3, 4 millimeters. So they're 4 millimeters apart. Get this. I'm going to change my snap grid back to 0.1 millimeters and move over 1 to the left on my keyboard. So now they are 3.9 millimeters apart. Okay. That was easy. That was cool, right? Get ready for this part. Let me zoom in here because I want to show this. I want to see this. This is my favorite part. I'm going to duplicate the part. There. Because I duplicated this part and moved it 3.9 millimeters and then duplicated this part, it made another one 3.9 millimeters away. So I've got 3 holes 3.9 millimeters apart. I'm going to make them a group. Poof. Now we can put them right in our part, just like that. Cool. But now so I can center it. That's the fun part now. Once again, I can do this centering thing. So let's center it. Let's line it up centered. Poof. But now I need to measure. I need to know how far this goes from the edge, right? Because that's the edge right there. So let's zoom in on this. I'm going to put this exactly on the edge. That looks like the edge. It's like as close as I'm going to get to the edge. That is less than 0.05, I'm going to say, from the edge. So we're going to call that the edge. And once again, I'm going to center it. Make sure it's centered because I moved stuff around. And I'm going to come back to our part. Dun, dun, dun. Now I need to measure how far this is from the end as I do some flipping here. Ready? So we're going to measure this right here. I'm going to hold with my finger right on the tip and say that this is 2 millimeters from the edge. Almost exactly. I don't know if you can catch all of that. 2 millimeters from the edge. It's so close to 2 millimeters. Oh, wait. Nope. Let me pull it away just for a second here, just so I can... Yep. 2 millimeters. So it's 2 millimeters from the edge. So I'm going to come back to our part. I'm going to snap my grid to 2. Dun, dun, dun. We're going to move this part 2 millimeters right there. Poof. That's it. There we go. We have a 3D shape of this part right here. Check it out. Let's go to home screen. I'm going to flip around. I'm going to flip to the top view. And we're going to zoom in right there. And I'm going to hold this up to the camera. Maybe over here. There we go. Tell me that doesn't look the same. I think it looks pretty good. And that's where we're going to kind of leave it right there. So check it out. Let me bounce back and forth. Kind of looks the same. Yeah, it's pretty close. So now we can make some models with this, right? We can make parts. We can do things like we know that our parts, that our robot does this thing. Our robot catches here on the eyes. So now I can share this workspace with the design team, and we can all try to come up with our own ideas on how to fix this. But we need to stop that part from hitting here, which is what happens. And I've got a few ideas. I've got some thoughts on this. I'm thinking something like that could stop this. That looks so easy, right? And of course, that actually turns our robot into a bird. Our robot would start to look like a bird if we did something like that. That looks a lot like a beak, right? And that's a super simple fix, right? we just drill another hole right in there, right in the middle. We just put another hole like right in the middle. I could do this just as an example. I could do the 4x4 right there and put this whole, line this hole up like that on our other holes. Like I said, just an example, and kind of line that up, and all of a sudden we have this part. Of course, I'm making it much easier. We'd have to have a like a tapered end in the bottom to hold a screw in, that kind of stuff. But you get the idea. We'd have to flatten this out a bit. But I'm going to zoom back out of that and get rid of that part. This is just one idea. I think what else could work in here? Maybe a cone like that. I don't know if the cone would work or not. I suppose if we flattened it a little like a mouth, or made it a lot wider, something like that might work. To kind of keep our parts apart. And I suppose if you were going to do this, you could probably carve out some of the edges so that it fits right on the eyes. And we can try all kinds of things. But the fun part is now, whatever parts we make, we can share. And I can export out of here as a file and print it. Oh, look at that. There's an option to 3D print now. So I could send this right to a 3D printer. Well, my 3D printer is not everything in there. But I can select the shape and download it and put it in Cura on my end. And we can start trying our examples. But for now, I'm going to delete those parts. And I'm also going to come back and, hey, hi, how you doing? I'm going to come back and just I kind of covered a little bit of that. And just to come back and chat again and finish this last little part. I'm actually running over the time I usually set aside for this. And I'm cool with that because this is actually a really, really good project. And I'm really, really happy with the results. What we have looks a lot like this in the model, and we can now work with this in a digital space. That's the whole idea. We didn't have that part in Tinkercad. We had something that looked like it from Arduino's library, but that part didn't work like that. And we don't need the back, the socket, because the socket's not part of anything that gets mangled or caught or anything else. What we really needed is to make something that hits the front of this. And now we have this in a workspace. We have this up there in a workspace, and we can actually like build parts that fit on it, and that's the super cool part. So now we can work with this in Tinkercad, and then I can grab the models for a group, and I can print them, and we can share them, and we can try different things, talk about what happens. We have a Slack channel for this. There are all kinds of ways that we chat about this. Maybe next week we will have something for you. Like I said, it's a fun group of veterans, volunteers, and people. So there's not a lot of stress behind the design plan. It's not like we're engineers putting in 14-hour days and stressed out or anything. This is fun for us. This is the cool stuff that makes us stay sane when life gets stressed. We can sit and model and do this kind of stuff, or we can walk away and go for a walk, or play with a dog, or any of those other things. So I'm going to set that back down in our space. We already did this and moved a battery box. That was cool. I dig it. It worked out so well. I'm already printing more of them for the rest of the team, and yeah, that's about it. I'm gonna wrap up. I'm gonna close, and I'm gonna get a glass of water because I was choking earlier. All right. Saturday there might be a highlight reel of Battle of the Bots. It'll be live next Saturday. So this Saturday we'll kind of replay some highlights from the last few years of running the program. Get to show some of the cool stuff that's happened since we started Battle of the Bots in 2019, and I think that's it. Don't do anything crazy. Don't do anything I do, and take care of yourselves. Good night. I gotta find them. I gotta find the close button. I moved everything